And we're back. Okay, so let's see. This time it's x squared. Oh. Okay. I got distracted. I was doing the derivative for a second. All right, so let me check the y values here. Yeah, I'm not checking the derivative values. So let's see. We got negative 0.6. Negative 1 is negative 1. 1 is 1, and 3 is 0.6. Okay, so this time, neither of our endpoints, oh, I didn't actually say my answers for the last one. So on this one, I'd say my absolute min is negative 1, and my absolute max is 1. Notice this is unhelpful because the x and the y are the same in this one. Let's go back and talk about this one really quick. So this we'd say our absolute min was 0 and our absolute max was 0.25, right? We give the maximum value and the minimum value, the output values that we get, the y values. All right, number 5. Fiv is f of x is equal to 3x to the 2/3 minus 2x plus 1. Cool. All right. So if we take the derivative here, bring the 2/3 down, that's 3 times 2/3 x to the, then we subtract 3 over 3 from this, right? And we get negative 1/3 minus 2 in the end. So let's just do a little bit of simplifying here. So the 3's cancel. This is 2x to the negative 1/3. 2 over x to the 1/3 minus 2. And this is our f prime. So we want to set this equal to 0 or undefined. Okay? So what we do is we say, hey, is there anything that would make this undefined? Oh, if the denominator was 0, we would have undefined. So it turns out that this, we get an undefined when x is equal to 0. Was that too fast? The derivative of this is undefined when x is equal to 0 because we have an x in the denominator. And that's a problem. Oh. This says negative 1 is not actually included in our interval. So we'll talk about that if we need to, if this turns out to be the highest y value. So, okay, so we'll add 2 to both sides. I'm going to multiply both sides by the x to the 1/3. Also, I just realized I haven't been paying 100% attention to whether or not this is on camera until just now. So I hope you've been able to see everything so far. I'm sorry. X to the 1/3 is equal to 2. Nope. I divide both sides by 2. I get 1. Uno. So how the heck are you supposed to get rid of one of these? What you do is you use the reciprocal exponent. So it's 1/3. Take both sides to the 3 over 1. This is pretty nice. 1 cubed is still 1. So these are the 3 values that we're going to check. Since this is not trivial to plug in by hand, I'm going to do this by hand. We need to talk about this exponent and how this works. So when it feels like busy work, I just like to use my calculator, but this is not busy work. For some of you it is, but we got to talk about how the heck this works. So for, no, even in this case, with 1, powers don't do anything, but negative 1 powers start doing things. So negative 1 to the 2/3. What this means is this means negative 1 squared the cube root of that. It's also equivalent to the cube root of negative 1 quantity squared. So if you square it and then take the cube root of it, you actually get +1 this time. So this leaves us with +3. Then the double negatives turn to +2. So 3 + 2 + 1 is 6. Now we try 1. So 1 is trivial. For this, it's just 1. And so this time we get 3 minus 2 plus 1 is 2, right? Yeah. Then that's just 1 plus 2. And then our last one, almost wrote a -8 there. For our last one here, so 8 to the 2/3, this is this idea, right? You can either take the cube root of 8 first and then square it, or you can square it and then take the cube root. Personally, I take the root first if I know it. That way I get a number that's easier to deal with when I'm going to go square it. Because cube root of 64 is harder than the cube root of 8, I guess. So cube root of 8 is 2. Square that, you get 4. That's 3 times 4. Minus 16 plus 1, so that's 12 minus 16 plus 1, that's -4 plus 1 is -3. Okay, so this -1 is a problem. So here's the thing. This is a subtle detail here. We've had brackets the entire time. So basically, like, what's happening if we look at this on a graph is at -1, at -1, we've got an open circle at 6. At 1, we've got a dot at 2, and at 8, we've got a dot down here at -3. So I don't know exactly what it looks like, but some kind of curve. Here's the thing. What's the lowest this gets? Down there at -3, right? So there's our abs min. Here's the problem. What's the highest this gets on this interval? We never get to 6. Shoot. So, like, is the highest 5.9? Well, I can get higher than 5.9. I can get higher than that. I can get higher than that. Yeah, you get the point, right? Maybe you don't. So I can keep on making numbers that are closer and closer and closer to 6. And if you pick a number, I can pick another number that is halfway between whatever number you picked and 6. You know, this is one of those paradoxes, right? Pick the closest number you can think of to 6. You know, oh, 5 with a zillion 9s after it. Okay, that's right here. Well, like, shoot. There's an infinite number of numbers between that and 6. So let's say we picked the one that's halfway. Now that one, 5 with a zillion 9s and like a 5 at the end is right there. But there's an infinite number of numbers between that and 6. There's never going to be a closest number. There's no absolute maximum value. Don't get me wrong. It's never over 6. It's not even 6. It's a number that's less than 6, but there's no absolute maximum number. We don't know that absolute maximum number. So splitting hairs here, but since that was not closed off, we can't say 6. That's a minute detail, but it was worth discussing. Sorry. All right, number 6. Cool. Absolute value. Hopefully you found this part of the video where I explained to you the derivative of the absolute value. Shoot, I guess I should teach this in class at some point. The derivative of absolute value is isn't it just x over absolute value of x? So So here's the rub on absolute value. It's just the function, 2 over the absolute value of the function. I'm pretty sure. Dear Google. Yeah, okay. So I can explain why this is what it is. I just want to make sure that I had the right thing. I think technically you can do either one. And if there'd been like a 3x inside there, we'd have to do chain rule and multiply by 3 at the end of it. Anyway, sorry. So the reason this is true is because we've got, if you just think about this on its own, the absolute value graph is a V like this. And for half the values, it's just regular old x minus 2. And for the other half of the values, it's the absolute value of x minus 2, which turns out to be negative x plus 2. When we're dealing with when the inside is negative, we take the opposite of everything. So it's either, the derivative is going to either be -1 or 1 at any given point. And the way that point is determined is the -2 in there. So this is going to be f prime of x. Okay, so when is this derivative undefined? When x is 2. When is it 0? Never. 0 over 0 is an issue. So when x is 2, we've got an ish. So if we're going to check our interval, -2, 2, and 5. So I'll plug in -2, I get -1, because I get, that's -4, you take the absolute value, it's regular 4, and then you subtract it. Then I plug in 2 and I get 0, so I get 3, and then I plug in 5. 5 minus 2 is 3, 3 minus 2 is 0. Okay, so this is our max, this is our min. All right, real quick. Let's say f of x is equal to the absolute value of x squared plus 5x minus 1. That means f prime of x is equal to x squared plus 5x minus 1 over the absolute value of x squared plus 5x minus 1 times 2x plus 5. So it's just, you take the original over the absolute value, multiply by the derivative of the inside. Normal chain rule business. Okay, 2 more. Number 7. F of x is equal to sine squared x plus cosine x. And we're only looking from 0 to 2 pi. Okay, so when we take the derivative, we get f prime is equal to 2 sine x cosine x plus, minus sine x. So we bring the 2 out front, leave the inside alone, then multiply by the derivative of the inside, right? Chain rule. So if I'm solving this, I can factor a sine x out and get 2 cosine x minus 1. So now we're setting each of these independently equal to 0, and I'm going to do my non-unit circle approach to these. Sine, like not memorizing the coordinates. I need sine of x is equal to 0. So if I'm on here, I do need to know that sine and y are together. So I need a y coordinate of 0. Well, that's going to occur here and here. Right, if we're thinking about that. Those are the 2 places where my y coordinate is 0. So that's at 0 and at pi. Oh, so 0 is actually one of the places I'm supposed to check. Pi I'm supposed to check as well. Now this one, this fits the less regular scenarios. The up, down, left, and right ones are not as easy to do without knowing anything about the unit circle. I'll add the 1 to both sides, get 2 cosine x is equal to 1. So cosine of x is equal to 1/2, right? So here is what I think if I'm not going to use unit circle knowledge. I can draw triangles in butterfly directions, right? And it's supposed to be 1/2 is cosine, which is adjacent over hippopotamus. Adjacent over hypotenuse. So if this was theta, then that would be 1/2, which directionally makes sense. Over here, if this was theta, 1/2, no, we went left. This actually would be -1 here. So I know that this triangle's out, and so is this one, because we go -1, 2. And the thing with doing it like this is that hypotenuse is always a positive number, and this will always work. The only thing is, so these are 2 different triangles. They both have an adjacent side of 1 and a hypotenuse of 2. They both work. So you need to figure out what kind of triangle this is. If you know your special right triangles, you know this is a 1, 2 square root of 3 triangle. And 1, 2 square root of 3 is a 30, 60, 90. Big goes with big, little goes with little. So biggest angle is 90. That goes with 2. 60 is middle. 30 is little. So that means that 1 is across the street from 30. And root 3 is actually less than 2. It's 1 point something. So, this is actually a 60-degree angle right here. And I use the memory device that there's 60 and there's 30, and there's pi/6 and pi/3, and they don't go together. So pi/6 and pi/3 are like reversed. So 60 is pi/3. So I got pi/3. And then I also have this pi/3 right before we complete the unit circle, or right before we complete 1 full revolution. So, because this isn't technically a unit circle, because my radius isn't 1, but whatever, you don't care. So that's 1/3. What's a third right before we reach a full revolution? Well, remember, a full revolution is 2 pi. So take away pi/3 from that. Let's see. 2 pi is equal to 6 pi over 3, right? Take away 1/3 from that, and you get 5 pi over 3. So that's how you do it. There, I didn't have my coordinates memorized, and I was able to do it. Now, if you have your coordinates memorized, way easier, way faster. But that's just like somebody who knows what 15 times 15 is in their head instead of having to do 15 times 15 and find out that it's 225 this way. It's a times table. That's all you memorized. All right. So now I got to go back in, plug these into the original. This is also not something that's trivial, so let's actually do it. If you know what you're doing here, just do it. You don't need me to do it for you. If you don't know what you're doing, that's what I'm here for. So I'll plug in 0. Well, sine of 0 is 0. Cosine of 0 is 1, so that's just 1. Sine of pi is 0. Cosine of pi is -1. Now we got this one. This one's fishy. Let's go back to this one. 2 pi. 2 pi, it's easy. So 2 pi, sine is 0, cosine's 1. Okay. Let's see what happens at 5 pi over 3. Let's see if it breaks out of this -1 to 1 business. So 5 pi over 3. So remember, that was down here, right? That means that, this is a 1 and a 2. This is a square root of 3, but this is a negative square root of 3. So what's sine of our angle here? -√3 over 2. We're going to square that, and then we're going to add cosine, which is 1/2, adjacent over hypotenuse. So let's see. if you square this, you get the top is 3, the bottom is 4, plus a heaf. Let's see, that's times 2/2, so 3/4 plus 2/4, 5/4. Look at that, we get a number that's bigger than 1. So now we have an absolute max and then absolute min. All right, final round out of paper. Haha, I found a piece. Oh, good. This one looks nice and relaxing. So the year that I'm filming this, we've been doing a lot of learning remotely, and so I'm using a lot of videos and stuff, and I'm like, wait, I taught this already? And now I remember the video now, but oh goodness. All right, so f prime of x. All right, so I know I'm checking what? I'm checking from negative e to e. Remember, e is 2 point something. So the derivative of ln x is 1 over the insides, right? And then we multiply by the derivative of the insides. So I like to put that on top and just put the 2x up there. Minus uno. Okay. So let's set this equal to 0 and pause for just a moment. Does this ever equal undefined? Does that ever break? You just think about that. It would break if this could ever equal 0. 1 plus, oh, it's a variable. When is this gonna equal -1? Oh wait, it won't. It's squared. Odd powers mess these up. Odd powers bring in problems. Man, my voice is getting like, somebody needs to drink some water. I will drink water in a minute. Okay, so I'm gonna add 1 to both sides. Multiply both sides by the junk. Sorry, the denominator. Then we'll subtract the 2x from both sides, get x squared minus 2x plus 1 is equal to 0. Oh, this is very nicely factorable. Let's say you don't know how to factor. Well, just remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops. You can always do this. I don't know why you would, but you can. Hey, wait, that's 4 minus 4, that's 0. It's over 2. Wait, it's just 1. Personally, I would factor this and I'd recognize, oh, this is just x minus 1 and x minus 1, or just x minus 1 squared. And so x is equal to 1 when we set them equal to 0 and solve. Regardless, 1 is our critical number. Go back, plug in. Oof, not trivial. Okay, let's do this. It's ln 1 plus x squared minus x. All right, we're plugging in negative e first. That's e squared. Minus negative e, so that's plus e. Guess what? That's it. That's all you can write. Nope. There's no rule that lets us break apart a plus inside a log. There's a rule that lets us combine 2 logs together that are added. All right, let's the other one is going to be what? ln of 1 plus e squared minus e. Whoa. We'll talk about, without a calculator, how to determine which of these is the least and greatest. Don't worry. Then we'll plug in 1, and we get ln of 2 minus 1. Don't know why I put that in parentheses. You would normally just see that as ln 2 minus 1. Okay, let's figure out now which of these is the least and which of these is the greatest. So, 1 plus e squared. Let's think about this approximately, okay? Well, e is 2.7, right? So we could round this, we could almost think about this as 3, so 1 plus 9. This is, this is a little bit less than 10, but it's, it's in the realm of 10. So ln of 10, what would that be? This is e to some power gets us 10. What power do we have to take e to get 10? Well, somewhere around 2. So we could be like, this is going to be 2-ish. Let me see how off I am. ln of 1 plus e squared. Yeah, 2.126. Okay, so it's somewhere around 2. And then we're adding e, which is somewhere around 3. So this is somewhere around 5-ish. With this one, that's somewhere around 2 minus e, minus that somewhere around 3. So this one's like -1. So we got close to 5, close to -1. Now we got to figure this one out. ln of 2. E to what power gets us ln of 2? So e is more than 2. So ln of 2 is going to be a value less than 1, but it's not going to be 0, right? Because e to the 0 gets us 1. So this is going to be somewhere between 0 and 1. So this is somewhere between 0 and 1. We're subtracting 1 from that. So we're getting negative point question mark. Negative point question mark is not more or less than either of these. And so this is going to be our max, and this is going to be our min. So that's how we arrive at our answer without knowing exactly what it is, but being able to definitively say, yes, this is more, or yes, this is less than the other ones. So just in case you didn't believe me, there's that one. We already did this one. Let's do the very last one. Oh wait, well, okay, so we can do plus e, and then we can do minus e. So, oh wow, I was cutting it a little bit close there, but I was right. Cool, I hope the video's been helpful. Let me just make sure. I thought that was the end. This is the end. All right, cool, so that should help, and I'll see you around. Bye.